Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with spectroscopy for chemistry. This is lecture number 36 for UV visible spectra, and in this lecture I will start numericals for Dyne system. So first of all we will take Dyne system. So suppose this example is given. Here you have to see at least two alternate double bonds. That will be your main system, and here there is no ring, so we can start from anywhere, but this will be the best thing to do. So this is your system, okay, and here both double bonds are out of this ring, there is no ring. So here we have open chain Dyne system, okay. So it is called open chain or acyclic Dyne system. And we have to add 217 nanometer for open chain Dyne system. This I have already explained you that you have to consider the amount of the value for different systems, and for open chain Dyne system this is the value, base value for this one. Okay, now we will see if there are any extra conjugated double bonds present or not. Matlab, if there is extension of this system is there or not. So again here there is single bond and then double bond, so we can extend this up to this. Now we will see whether this double bond is in extension with the system or not. Yes, because there is single bond and then one double bond, so again we have alternate system up to this one. Now next one, the double bond is over here, but here you can see there are two single bonds and then when there is double bond, that means this double bond is not in conjugated Dyne system, okay, it is out of the system, so do not consider this. This is out of Dyne system, so we will not consider this double bond. Why? Because it is not in conjugation with the system, so let us forget about this one, but these are the things. Okay, now how many extra conjugated double bonds along with the system? Then there are two alternate extra conjugated double bond in the system, so we will take this way, two extra conjugated double bond for each double bond we take 30. So there are two alternate double bonds and therefore we will take 60 nanometer for extra conjugated double bonds. Okay, so this is very important. Now, is there any exocyclic double bond in the system? That we'll have to see if there is any exocyclic double bond present. There is no exocyclic double bond because there is no ring. So for that we will add 0. But we have to add something for that. Okay, next is substitution. So first of all, let us see substitution. Alkyl ring residue substitution. Ring residue. RR. So with the system, this is carbon of the system. Now here this carbon is out of the system, so this is one ring residue. Then we have OH group. OH group does not fall in ring residue, but it is one of the substituent. Then third carbon of the system is here, and here you can see one more ring residue. Then we go ahead. Here there is methyl group over here, so this is also ring residue. Then here we have bromine as substituent. Next to this carbon has nothing because those carbons attached to this carbon are in the system, so we will not consider this here anything. Next again nothing. Then we have chlorine over here and this one. So except functional groups, we have 4 alkyl groups attached to this. So there are 4 ring residue. For each one we will add 5 nanometer. So we have to add 20 nanometer for alkyl substitution. Now there is substitution of OH group. So this substituent OH group, which is having 0 value. So we will add 0 nanometer for OH group. Then there is bromine. And for bromine we have a value of 5 nanometer. Don't worry, all these values will be given to you in exam also. So you don't have to remember all these values. But you should know that whether these groups are in the system or not. Then there is a chlorine in the system. And for chlorine also we add 5 nanometer for this one. Okay. Now for Dyne system there is, is there anything left? Just check it. OH, bromine, chlorine, both are this. Do not consider this one because it is not in conjugation. So we will not consider this anything from this one. So our system is only this much. And there are 4 ring residues, 1 chlorine, 1 bromine, 1 OH group, and 2 extra conjugated double bonds. There is no exocyclic double bond. So I think that's it in this numerical. Now you have to add all this. Now you have to add all this. And total of this will be lambda maxima. That you can calculate easily. Okay, so this is a matter of mathematics and I am not involved in that. So you better calculate it and find out lambda maxima of this numerical. Okay, so this is about the numerical of Dyne system. I'll take one more numerical related to Dyne system. Let us take this one. The second one. So this is an example given to you. Now you have to find out which one is a system. Okay. So first of all, see which one is a system. There are 2 possible systems over here. One in which these 2 double bonds are in one ring only, and here one double bond is in B ring, another is on C ring. Remember one thing, this is also very important, that if such bracket is given to you in the example, that means this is extended ring. Sorry. This is an extended ring. Yaad rakho. So it is an extended ring. If this kind of bracket is given along with these 2 ends, that means it is an extended ring. Now here we'll have to consider the system, and I think this is the best system, and it is homoannular system. Next is heteroannular, but homoannular has more base value, and therefore we have to consider the system which is having more base value. So our original system is homoannular Dyne system. And for homoannular Dyne system, the base value is 253 nanometer. Okay. Now we have to see extra extension is there or not. That means extra conjugated double bond present or not. And how many? So here we will go with this system. Extension, here single bond, then double bond. So this is an extension. Remember here single bond and double bond. That means this double bond is not in a system. It is out of the system. Do not consider this. Okay, it's a false, and therefore please don't consider this double bond in a system. It is not in conjugation at all. Okay, so our system is having only one extra conjugated double bond. For that we will add 30 nanometer for this one. Next is exocyclic double bond. We'll have to see exocyclic double bonds are present or not. For exocyclic double bond, you know that one carbon of double bond should be in the ring and another carbon should be out of the ring. Let us take rings A, B and C. So first of all, take A ring. Is there any, oh, of course, here also there is one more ring, D ring. This is also considered as ring. Remember this. So is there any double bond which is exocyclic to A ring? Check it. This is not the system, so we don't consider this. Now this is considered as first double bond, second double bond over here, and third double bond is in C ring. So in B ring there are first and second double bonds. But if you take A ring, this double bond is endocyclic because both carbons are in this ring. So these two carbons are in this A ring, and therefore C1 and C2 both are in first ring A, so we will not consider this. Okay, so let us take this one as there is no exocyclic double bond for A ring. Now for D ring, C1 C2 double bond is exocyclic because C2 is in D ring but C1 is not in D ring, and that's why one exocyclic double bonds, this one is for D ring. Remember this way. Okay, now C2 C3 C4 double bond, C3 C4 double bond is again exocyclic for D ring as well as exocyclic for C ring because C4 is in C ring, C3 is not in C ring, and that is why this is for two rings. This is double exocyclic for two rings. Okay, now we'll take this double bond which is of C5 and C6. Okay, so C5-6-6 double bond is exocyclic for B ring but not for C ring. Okay, so how many exocyclic? 4. For each exocyclic we add 5 and therefore total will be 20 nanometer. Remember C3-C4 double bond is exocyclic for both rings, D ring as well as for C ring. Okay, so this way we have to see exocyclic double bond. Next is substitution. So first of all we will see alkyl substitution, ring residue. We start from here. This is a ring residue for C1. This is also ring residue for C1. For C2, this is ring residue. Next is C3. For this one is ring residue for this C3. Now for C4, we can consider this as ring residue. For C5, this is ring residue. For C5, then C6, of course, this is ring residue. Okay. So total number of ring residue 1, 2, 3, 4. Sorry, again 1, 2, 3, 4, 5, 6, 7. So 7 ring residues into 5, 35 for this. And of course, this group is also present, NR2 or NCH3 twice. So for NR2, we add 60 nanometer for this one. Okay, anything else left? Just check it. I think nothing. So then you have to add all these values and find out lambda maxima. If anything is left, please let me know. I may commit mistake, but if there is nothing, please add all these values and find out lambda maxima for this compound. So that's it in this lecture. Thank you so much.